Hello everyone, and welcome to our guided tour of Siemens additive manufacturing capabilities. First things first, I should probably introduce myself for those of you whom I haven't met yet. My name is Ashley Eckhoff, and I'm a member of the additive manufacturing program here at Siemens Digital Industries Software. For the session today, I'd like to spend a little bit of time taking you on a tour of the Siemens additive manufacturing solutions. Then I'm going to turn things over to my colleagues in Germany so you can see how we help companies industrialize additive manufacturing through our additive manufacturing experience centers, both digital and physical. So let's get started. I thought I'd begin today by going through some of the additive manufacturing capabilities that Siemens has built into our software suite. Let's begin with a quick introduction of the Siemens end-to-end integrated software process for additive manufacturing. So Siemens has been working with additive manufacturing since almost from the beginning of the technology. And as we've talked with our customers in the field, we find that they have challenges across the entire digital thread. And these customers have questions at every step along the way. So you need to understand things like, how do I assess opportunities and optimize my designs for additive? How do I go about finding and using the proper materials? How do I qualify my parts, and how do I avoid print failures? And how do I optimize my efficiency and orchestrate my production? Finally, of course, how do you monitor and automate the production to provide traceability and gain insights about the production process? And all of these things kind of lead into how do you produce quality parts on time and at scale? So at Siemens, we've worked hard to answer that call and to design an end-to-end additive manufacturing software solution that helps our customers answer those questions and alleviate those problems. Our current end-to-end software system for AM is built around the idea of digital twins. So there's a digital twin of the product, which is a CAD model that might be optimized. And there's a digital twin of production, which includes things like print simulation and build tray setup. Both of these virtual twins lead into the physical world where we have real production and finally a real product. Now, at the beginning of the additive manufacturing workflow is the virtual product. So let's talk briefly for a bit about how a company might create the virtual product using Siemens software solutions. Most product designs begin as standard CAD designs, and this is the case for NX, our high-end CAD system as well. Normally, a designer would craft a part using standard design tools like extrudes and Boolean operations. And of course, all those tools are available inside of NX. But there are also tools in NX for additive manufacturing, specifically for the design of additive manufactured parts. The lattice capability you see here is one such tool. There are a multitude of options for creating lattice structures built inside of NX, and you can see a few of those here. You might also begin your design with a topology optimized shape. Now, NX includes the ability to topology optimize geometry for material usage or weight. However, in this case, we're working on a part that has been topology optimized for fluid flow using our Star CCM Plus product. In any case, if you start with topology optimized geometry, you'll be working with facet or mesh geometry, which is the green body you see here. However, this is no problem for NX because you can easily mix CAD mesh geometry with CAD geometry. In this case, we're working on a detail feature, the little yellow tab, which is standard CAD NURBS geometry. Now, using NX, we can easily adjust the exact CAD geometry or the facet geometry, and then we can unite those two together. The system works on the geometry regardless of what type of body you're using, be it a straight up CAD body or a facet body. Now, once you have the part you want to print, it makes sense to optimize the printing of that part, not as in topology optimization, but as in optimizing the actual production. So for example, Siemens has software for optimizing the orientation of the part in the build tray. This helps minimize distortion, minimize material usage, etc., so that your production is optimal and your part will print with quality the first time. Now, this particular system, called the AM Build Optimizer, is cloud-based and uses parallel processing running over 100 different orientations in parallel to find the optimal orientation for your part in the build according to some weighted inputs that you give the system. Now, once the part has been designed and you've optimized the orientation that you want to populate your build tray, in NX, we have integrated 3D nesting so that you can take a handful of parts and optimize their position in the build tray. Now, if you've optimized the orientation of the part ahead of time using the build optimizer, that orientation will be honored as parts are placed into the tray. In this case, you can deeply impact the time it takes to print your parts by how they're packed into the build tray. So for example, minimizing the height in the Z direction can often result in much faster printing using most print technologies. And finally, depending on the production technology, you might need to add support structures. So again, this is capability that is part of the Siemens end-to-end additive manufacturing solution in NX. With many of our systems on the market, you are going to have to use a third-party tool to design these support structures. Sometimes this would even come from the hardware vendor. With NX, we've worked really hard to partner with as many hardware vendors as possible to build this capability into our software. And what this means is that the build tray setup can be easily updated as the part you're printing changes or as you decide to add different parts into the build tray. So we've talked about some of the pieces of software that comprise the Siemens end-to-end additive manufacturing workflow, but there are many parts to the system and many more capabilities available. So I encourage you to have a deeper look into our AM software workflow by having a look at our AM blogs, our webinars, have a look at our social postings, or by contacting Siemens Industries Software directly if you have some questions that you would like answered. Finally, I'd like to turn things over today to a couple of my colleagues in Germany. Thomas and Nicholas are here to show you around our Virtual Additive Manufacturing Experience Center, or AMEC. The virtual AMEC is a digital twin, if you will, of the physical AMEC in Erlangen, Germany. Thomas and Nicholas are here to talk about how we use real-world examples of printed parts and printing machines to help companies understand how they can industrialize additive manufacturing. Now at the AMEX, you'll see not only NX, but also SimCenter, TeamCenter, OpCenter, MindSphere, and our additive manufacturing network. And you'll see how these programs interface with real-world printing and robotics equipment. So Thomas, Nicholas, thank you very much for agreeing to give us a look at the AMEC, and the floor is yours.
Welcome here from my side. I'm Thomas, and I'm guiding you today through the digital version of the Additive Manufacturing Experience Center. We speak about the industrialization of additive manufacturing, and from our point of view, the additive manufacturing technologies, which are from our side relevant for the industrialization, are four technologies. The first one is the powder bed fusion technology, where we can process polymers, metals, ceramics, and others. The material extrusion technology, where we see later on the robot really working with material extrusion, the directed energy deposition technology, and the jetting technology. And I think some of them are really interesting to have a small look like. Now today we can't touch them as in the real AMEC, but we can take them out, have a small look here. This is a part of a mold for producing drones, for example, but nothing what I want to present too much in detail. This here is a burner from a gas turbine, and our colleagues from Siemens Energy are using these burners in their gas turbines, and I will show you where they are built in. And this is such a gas turbine. They are really impressive and big, and these burners, we use 30 of these burners in this gas turbine, and they thought about printing these parts. In former times, they are produced by 13 different single parts where there's much effort for printing, for milling and drilling, for bending pipes and so on. Now, I turn a little bit around. We see here our partner wall of the AM Experience Center. If we go closer, you see many, many partners which we work together in different areas. And now, Markus, I'd like you to show us here in the digital version of the AMEC how you proceed with the digital twin of the product of this mold. Markus.
Yeah, thanks a lot, Thomas. So I'm now here sitting there where our experts could sit globally, basically. Everybody could join in for such a workshop with our customers here in the Digital Additive Manufacturing Experience Center. What you can see on my screen here now, that is a typical design for a Formula race car. So first of all, the part we want to talk about is this side panel here. That's the radiator duct of the race car. And basically to get to a mold for such a part, we create a block and basically just subtract the shape of the car or of the required panel. So I already prepared that. You can see that is quite straightforward. I'm going to move it away a little bit so that you can also see the inside of this shape. So that is how it looks like. And this is what we want to print now and produce in a very fast and innovative way. We have functions for printing on a planar surface with different patterns. We also have functions for printing on rotary surfaces and even for freeform surfaces. So now you can really see how the robot is depositing the material layer by layer. I can speed that a little bit up. You can also see that the tool is right in that direction where I told the robot how it needs to be. And it's moving. You can see here now the robot axes are moving and it's printing as it should do. And now you can see it has collected its tool and it's really chipping away the material. So you can see the live removal of the material here, how it's then removing layer by layer.
I want to now run with you a little bit or walk a little bit through the AMEC, and then we go in the next step of content to our manufacturing execution system. Here on the left side, you see the DMG Mori LaserTech 65 3D machine, where we can do with 3D with directed energy deposition, printing, turning and milling all completely in one machine. If we go a little bit ahead in our shop floor, you see on the left side HP machine representing the jetting technology, the newest HP industrial machine, the 5200. And what we also can see is an EOS machine, an EOS M300. This is a powder bed fusion machine where parts can be printed with metal powder bed. You see here the terminal of the machine and you see the machine printing. This is a quadro laser machine where 4 lasers are working in parallel on producing parts. And we have one more shedding machine here on this side. This is the color machine from HP. And all these machines have in common that they are seamlessly connected into the digital workflow. This means we can prepare the content, the data, the files as Markus did it for the robot now, and then we can send it seamlessly up to the machine. But now let's go to the shop floor. And on the shop floor, we have usually colleagues which are running the machines, and they can now go to the manufacturing execution system. It's called Ops Center, and here they log into the system. You see many orders here in the AIM Experience Center. Now we deselect the other technologies. We only want to see the radiator duct, what Markus has prepared now. And these are the different steps you see now here. The different steps are what the worker has to do. One step is to prepare the robot. If all is done, we can click it as complete, mark it, select the order again, and then we see the first step is already green. It's marked, and the next step here, what we need is the pallet handling. This means we have to scan the pallets if they are really the right ones, which we use for this order. And in this point, we have complete traceability of the complete project. This means from the beginning, from cut, come, with which file version do we work, who is operating the robot, which batch number of pallets are in. Now we give in the batch number and checking it. And now the system tells us, oh, there's a mistake. This is the wrong material, what you inserted. And now we correct it. Now the material is successfully. This means we have also quality checks in the software to avoid failures. And the next step is really now we can send the file directly to the robot, and then we can start the robot with his printing process. You see all seamlessly cut, CAM, op center, all steps are in one flow in the seamless digital AM flow. We go out of the station, and now let's look to the robot. I turn right, and you see here our robot. He has already printed the complete part, the air duct, but we could restart it. This is the advantage on a digital version for printing. And we also could tell him, make the milling. Yeah, I start with the printing. And we have one advantage here, a big advantage in the digital version. I can switch off the glass. This does not mean that we go into the area of the robot. We have here still a wall where I can't go through, but we can check in detail what Markus showed us before, if the robot really is doing the details. If I speed up a little bit here as well, you see he starts the same thing, he prints the part, and it goes on. And if we go now to the milling process, we can see a similar thing, but I switch on to another position, sorry. And now you see how the robot is taking the milling spindle and starting milling here in the same way as Markus showed us, but here we are in a digital picture of the robot, not the digital twin. This is what Markus showed us, yeah?
Thanks a lot, Thomas. So meanwhile, I walked over to the real robot in the AMEC, and as you can see behind me, it is already printing. The average print time for the radiator duct mold of the race car is about 8 hours. So I already started printing it this morning. The setup for it took roughly about 20 to 30 minutes. So I needed to check the pallets, I needed to refill them, switch on the cabinets, and of course also some warm-up time for the extruder. So then it's very important to start the print process very slowly, because you need a proper bonding between the part and the build plate. It also has a slightly ripped surface, as you can see. And this ensures a proper bonding between the part and the build plate.
Okay, we come back and make a last overview for today. And this is again now the summary about the industrialization of additive manufacturing, what we offer as Siemens. Well, there are 6 points what I want to give you as a summary for today. And what is it, the industrialization of additive manufacturing? The first point, it appears in a few seconds, is about increasing the efficiency by seamlessly integrated software. What I showed you, we have the seamless integration from CAD, CAM, Team Center, Op Center up to the machine. We can realize the first time right printing. With the digital twins, we see the failures before they appear on the machine. We utilize full data traceability. We know what we do in each step of the design and production. We can improve machine quality and efficiency by using Siemens Industrial Automation Solution. You can expand your business opportunities by connecting to the AM network, and what we didn't show in detail, but we have many consultants who can support you in different areas. If it's connecting machines to MindSphere, bringing more intelligence to it, having artificial intelligence and so on, this is all where we can speed up your way to industrialize additive manufacturing.
Thank you, Thomas and Nicholas, for joining us today and giving us a tour of the AMEC. Now, if you would like other people in your company to visit the virtual or physical AMEC, you can just do a web search for the term AMEC, A-M-E-C, and Siemens, and you should be able to find the page where you can sign up for a tour for yourself or any of your colleagues. And this brings our session to a close. I'd like to thank you all for your time, and I hope you enjoyed this small tour of the Siemens additive manufacturing capabilities. Please don't forget to tell us how we did with this session. I personally do appreciate the feedback. I'm always looking to improve so that you get the information that's useful to you. Thanks again for joining us today, and we hope to see you at a physical event in the near future.